In this video I'll be telling you what logistic regression is and the basics of it. So logistic regression is nothing but it's a classification of values where you provide certain values. For example, let's take this example where you have x1, x2, x3 and till xn. So these are the values which are provided for the logistic regression. So why logistic regression? So you want to find out, so for example in this picture, whether the given problem is a dog or not a dog. So so this is how logistic regression works. So a set of values are provided for the user to find out whether it's a dog or not a dog, or a cat or not a cat. So is it 1 or is it 0? So 1 means yes and 0 means no. So it's just a situation where there are only two possibilities. So it's always binary, whether it's 1 or 0, whether it's y or n, that is yes or no. So that's how it works. We saw the system using logistic regression to find out whether the image was a dog or not a dog. But how does logistic regression know whether this is a dog or not a dog? So I'm taking an example here of image detection. So to find out whether the image was either a dog or not a dog, you really need to understand what the image is, whether the image has a dog or not a dog. So you know that an image consists of several pixels, in fact thousands of them. So and every pixel is made up of three channels. One is a red channel, a green channel and a blue channel. So that's what you call as RGB, red, green and blue. So these channels are layered on top of the other using um, this this one layer, this another layer, this is another layer. So these are layered on top of one another. So we have an image array here. So the pixels of this image are 64 rows and 64 columns, consisting of three layers which has 64 rows and 64 columns each. So the image array is 64 into 64 into 3. So with this, what are these numbers that are present on the matrix? So these numbers are the brightness of each light. So let's take that is the topmost layer, and we'll take out 167 and 4. So what's the difference? So the brightness of this image, that is fourth row and fourth column, that is 167, because it is in the fourth row and fourth column. And we'll take third row and third column, that is image number this one, so which has 4 in it. So 167 has a higher brightness, but 4 has a lower brightness. So that's how you characterize an image. So this is for the red channel. Similarly, it will work for 8 and 18, where 18 has a higher brightness than 8. Definitely not the highest brightness, because there is always 2 to 30, but it depends on what color the RGB is offering in that image, that makes it characterize, or that makes it determine whether how bright the green channel is, the red channel is and the blue channel is. So let's take one first row and then the second column, where you have 67, 56 and 200, because only those are clearly visible in this image. So you have 67, 56 and then 200. Yeah. So these are layered on top of one another. So what do these do? They form a 3D matrix which makes you determine the characteristic of that pixel. So that is how the color is formed based on the image, based on the brightness of the channel. So when they come in layers, they form a color. And when these colors are presented in a form of a 3D matrix, it makes us find out what the image is. So you give several sample images, several dog images to the machine learning algorithm, and it you basically train the computer to find out whether a given image is a dog or not a dog. So based on its experience, that is, the experience is nothing but the examples you have given saying that this image is a dog and this image is not a dog. Whatever image the computer has stored in the system, it makes it find out that this image is nothing but a dog or not. So that's how you find out whether um, the particular image is a dog or not. So yeah, that's nothing but that was just a simple example using logistic regression, which is used in image classification. There are several examples to it. It can be nothing but whether um, the COVID-19 cases are gonna go high or not. So that's a yes or no question, right? So you can use logistic regression to find out those problems as well. Any problem which has a higher, that is discrete values. So whether any problem that results in a yes or a no statement can be used to find out the answer using logistic regression. So that's about it. Thank you for tuning in. Cheers.